Okay. I'm Mr. Smith. Sorry about that. It's a good way to start. And this is, I didn't give this to the class, but you can find this on maybe Gradebook Wizard, or you can probably go to that website I told you, advancedmathtutors.com, and it should be on there to download. Or you can just look at it on here if you want. I'm just going to run through this and do some answers here. Your testing class are going to look a little bit like this. So hopefully you can do all this stuff. Alright, number one, stuff we've seen many, many times. F of x equals square root of 3x, and we want the limit h goes to 0 of this difference quotient. Okay, so really this is finding the derivative. That's what this is saying. We are finding f prime of x. Now we've done the math for this a bunch of times. Let's switch to blue here. That'd be pretty cool. But is that blue? Let's make this a little fatter. Limit h is going to 0 of f of x plus h is the same thing as the square root of 3. I told you put in x plus h in parentheses wherever you see x, minus f of x, which is just the square root of 3x, divided by h. There we go. And hopefully by now you are so bored of this, you see square roots, you know you're going to have to do the conjugate, but before you do that, plug in h going to 0 just to make sure that you have to do some work here. So when you plug in h goes to 0, you're going to get square root of 3x minus square root of 3x up top, which is 0, and the bottom is just h, so that's going to be 0. So, what do we call this guy? Very correct, indeterminate. And what's it mean? More work. So, let's go ahead and erase that dude. Somehow, we'll cut him. There we go. Go back to the pencil. Alright, so what we're really going to do, now we know we need to do more work. We plugged in 0 for h, which means h has to cancel out, because we got 0 over 0. So h has to cancel out. So we're going to multiply this by the conjugate on top and bottom. So we're going to get 3 times x plus h plus the square root of 3x over, we need a parenthesis here, over the same exact thing. So we're just multiplying by 1. We're not changing what this thing equals, because that would be bad. Plus another parenthesis, plus square root of 3x. There we go. When you multiply that in, you know when you multiply by the conjugate, you get a squared minus b squared. So we're going to get the square root squared, which makes the square root go away. So we're going to get, and we'll distribute that 3 as well, might as well. 3x plus 3h minus 3x over h times all this junk. Square root of 3x plus 3h plus the square root of 3x. Okay. Now, these 3x's up top cancel, which, again, is always going to happen. Bam, bam, and you're left with just 3h up top. And now that those 3x's are gone, the h's can cancel because there's just 3 times h up top, h times all this junk on the bottom. H's will cancel out now that those 3x's are gone. So what we're left with here, let's go back to that blue, is the limit as h goes to 0. That's my dog. Of 3 over the square root. She is not happy. 3x. Oh no, this is supposed to be an h up here. I'm sorry about that. 3h. 3x plus 3h plus the square root of 3x. And if h goes to 0, then this term right here becomes 0. So we really just have, now we're just going to plug in h. The limit's gone, no one to write it anymore. Over the square root of 3x plus the square root of 3x. And the only thing we can really do to simplify that is make it 3 over 2 square roots 3x. There you go. No big deal. All done. Let's check out this next one. I'm going to erase all this. I'm getting better with this thing. We'll go back to the pencil. Alright, number 2. Let's scroll down a tad here. There we go. What's the domain of this thing? This is a random question for a limit test. It's just like a leftover from all that pre-calc review we were doing. I'm making sure you guys are still on the ball there. Well, to find the domain of this thing, I told you there's 3 things you're looking for. You cannot take the square root of a negative number, you cannot divide by 0, and you cannot take the log of 0 or a negative number. In this case, all we got to worry about is the square root. So basically, to find the domain, we need to find out where is 6x squared plus 5x minus 6 greater than or equal to 0. And anytime you have to solve an equation like this, it's best just to factor it. Now, I'm not even sure if this factors. 6 times negative 6 is what? Negative 36. What multiplies 9 and 4? Alright, this is going to factor. So let's see what it factors into. Negative 36. It's going to be 9 and negative 4, which means this is going to factor into, watch this trick here, you're going to love this. X squared, not x squared. Come on, Mr. Smith. X squared, God, I'm falling apart here on camera. X plus 9 times x minus 4, and you take this leading term up here, 6, and divide both of these guys by that. So this is going to become x plus 3 halves, x minus 2/3, and don't ask me why this works. It's not important. You bring this, the denominator, up to the front, and what you get is 2x plus 3 and 3x minus 2. And that is the factored version of this original thing up here. That guy. Anyway, we need this to be greater than or equal to 0. So what we're going to do, I'm running out of room here a little bit. We're going to delete all this stuff. Goodbye. Greater than 0, and again, I told you, make a number line up, because this thing's continuous, so it can only be positive, negative, or 0. We're going to find out where it's 0, and then check the intervals in between. So this is 0 at negative 3 halves, and positive 2/3, just by solving this equals 0. And now we just plug in a big number, or a number less than negative 3 halves. You can plug in negative 1,000,000. It doesn't matter. Any number back here to see what sign it is everywhere back here. We also know this is a parabola, so the thing's got to look like this. I mean, this is no surprise. So really, what's going to happen is it's going to look like that. So the bottom part, or the middle part, is going to be the negative. But anyway, plug in negative 100, you're going to get a negative times a negative, which is a positive. If you plug in a number between negative 3 halves and 2/3, like 0, this one's positive, but this is going to be negative. That's your negative. And when you plug in a number past 2/3 up here somewhere, like 1,000,000, whatever, you get a positive times a positive, so the whole thing is positive. So, as long as 6x squared plus 5x minus 6 is positive, this graph, y equals the square root of that, the domain of that is going to be wherever what's inside is positive. So that's right over here. X less than or equal to negative 3 halves union with x greater than or equal to 2/3. And you can write that in interval notation if you want. It doesn't matter. Okay, let's do the graph guy. Graphing limits should be fairly easy, I'm hoping. If it's not, I'm not saying that it's bad. I mean, we just need to practice more. But limit x goes to 2 of f of x. So let's find 2. That's right here. And you can see automatically on this side, we're going somewhere around 1, 2, 3, 4. And here we're going, on the right-hand side, we're going around like negative 2. Since they are both different numbers, a does not exist. Okay? Because again, we talked about it. If you're riding on the curve, headed towards 2 from both directions, you're not going to crash into yourself or each other or whatever. So that's, I mean, the limit doesn't exist then. For b, limit x goes to 4. Where's 4? Probably that asymptote there. I should make this a little bit bigger somehow. Whoa. I don't like that. How do I get rid of these guys? Oh well. 4 is this asymptote. And you can see on both sides, both of these parts of the graph are going down to negative infinity. So the answer is negative infinity. Alright, C. X goes to negative infinity. That is back here. If you follow along on this graph right here, you can see it's headed towards a horizontal asymptote. And anytime you see x going to infinity or negative infinity, they're just asking for the horizontal asymptote in that direction. And this is going to be at 1, 2, 3, 4, 5, like 5 or 6. This is hard to read because I did this by hand. Okay. D. Limit x goes to 12 from the right-hand side. So above. That's that plus there. So this is 4, 5, 6, 7, 8, 9, 10, 11, 12. Well, there's nothing. The graph stops at 12. So limit x goes to 12 from above. Well, there's nowhere for the graph to be here, so it's not headed towards anywhere. So that does not exist either. D. E. X goes to negative 3 from below. Negative 3 is this asymptote. We're looking at the left-handed limit, so the left side, which is this side over here. And that is headed down to negative infinity. Okay. F. X goes to negative 7 from below. That's this hole right here. And you can see both sides head to the same spot. Even though f of -7 is down here at -2, that's not what the limit's asking for. The limit is saying, where is the graph headed as x heads to -7? So before you get to -7, where's the graph headed? And the graph is headed to, it looks like about 2. From the left and the right side. So this is just asking for the left-sided limit, but they're both 2. G, x goes to 2 from the right. That's the right-hand side, obviously. So here's the right-hand side, and we're headed to 2. So we're following on this curve here. X equals 2, and that looks like it should be about -2. And H. X goes to -3 of f of x. -3 is back here at this asymptote. Well, the left-hand side goes down to -infinity. The right-hand side goes up to positive infinity. Since they do not go in the same direction, it does not exist. Alright, that was fun. Thanks for stopping by.